All right, welcome Algebra 2 to our lesson for the week. In this first lesson, we are going to try to explain to you what a logarithm is, and then hopefully teach you how to restate a logarithm as an exponential statement and evaluate logarithms, either doing it mentally, using mental math, kind of, or using a graphing calculator. We'll also talk about Desmos in case you don't have access to a calculator at home, so don't worry about it. So here we go. So to introduce you to a logarithm, first we need you to remember some things about inverses that you hopefully already know. You should be familiar with the fact that if you have an inverse, a function and its inverse, if the point a comma b is on the function, then that means the point b comma a will be on the inverse. This is what inverse functions do. They switch the x and the y values. So if a is the x value on the f function, then that means a will be the y value on the inverse function. And likewise, if b is the y value on the function, then b will become the x value on the inverse. Now, when you swap x and y values like this, what it does, one of the consequences of what it does is it makes the two graphs, f and the inverse of f, will now be symmetrical across the diagonal line y equals x. Okay, so let's take an exponential function, a simple one that you should already be familiar with. Here is f of x is equal to 2 to the x. We've got a table of values and we also have a graph of the function. If I told you that this was f and I asked you to find the inverse of f, I hope you could start to do that. Maybe the first thing I would suggest doing is switching the x and the y values. So if you take the table to the left and if you use it to create a table for the inverse, then that means that whatever was the x value, like -2, now becomes the y value. And whatever was the y value, like 1/4, now becomes the x value. And if you do that for the entire table, as I'm going to do here, then you have a table of values that you can use to plot points and start to get an idea of what the inverse looks like. Now the first few points are a little awkward to graph because an x-coordinate of 1/4 is hard to draw accurately, but I'll do the best that I can. And same thing with an x-coordinate of 1/2. But then from there it gets a little bit easier. So the next point is easier to draw accurately, and the next point, and the next point, and the last. And so if you connect those dots, you start to get an idea of what the inverse looks like. And hopefully you can see from this picture that the black graph and the red graph are reflections across the dotted line that I'm drawing, which is y equals x. So there you go. There's the inverse of 2 to the x. Okay, well here's the actual graph drawn with a graphing calculator. It's a little better looking than the one I drew by hand. You've got a table of values for the graph. You have a picture of the graph. All that you're missing now is a name for the graph. So what do you call this function? So here is the definition of a logarithm. This is what we call that inverse function you were just looking at. The logarithm, or log, sometimes we just say log instead of logarithm. A logarithm base b of y is written as log base b of y. That's how you should say this when you see this expression. Let me say that one more time. Log base b of y. It is defined such that the log base b of y is equal to x if and only if b to the x is equal to y. So you can see here that the definition of this logarithm depends on an exponential statement. That's what this thing on the right is that I just underlined. We would consider that an exponential statement because you can see it involves an exponent. This will maybe be a little bit easier to understand if we give you an example using some numbers. So let's look at one. So log base 2 of 8 is equal to 3 if and only if 2 to the third power is equal to 8. So notice how the numbers and letters are changing positions here. The b, whatever number you put here, moved over here in the exponential statement. So you can see that the base of the logarithm turns into the base of the exponential statement. Whatever the logarithm was equal to, that turns into the exponent. So you can see that the 3 turned into the exponent. And then whatever you're taking the log of, so the y value, that's what goes on the other side of the equal sign. So in this example, we were taking the log of 8, and that's why the 8 is on the other side of the equal sign. So we hopefully know that 2 to the third power is equal to 8, and that's why we would say that the log base 2 of 8 is equal to 3. So here are just several more examples of logarithms to help you get comfortable with what we're saying here. On the left-hand side, we have log statements, and on the right-hand side, we have the equivalent exponential statements. So on the left, if you didn't understand why log base 3 of 9 is equal to 2, I think it might be easier to understand it if you think of it as its equivalent exponential statement. Again, look at the top of the slide. Notice how the letters change positions. So the base of the logarithm becomes the base of the exponent. Since this was log base 3, that's why the exponent has a base of 3. Remember what the logarithm is equal to, that becomes the exponent. Since this log was equal to 2, that's why this exponent is a 2. So again, you may not understand why log base 3 of 9 is equal to 2, but I certainly hope you understand that 3 squared is equal to 9. So if you look at the exponential statements, I hope you recognize each of these is true. 4 to the 1/2 is 2, because remember, 4 to the 1/2 is really just the square root of 4. 2 to the negative 2 is 1/4, because remember, negative exponents just mean 1 over. So 2 to the negative 2 is really just 1 over 2 squared. And again, negative exponents, as we just pointed out, 1/2 to the negative 3, that would be 1 over 1/2 cubed. And 1/2 cubed is 1/8. So 1 over 1/8 turns into an 8. So if you understand all the exponential statements, then you should be able to see why the logarithms are what they are, because they're just rearrangements of those exponential statements. This is a little awkward, I know. It takes a little practice, but I promise the more you practice it, the easier it gets. So now that you have an understanding of the definition of a logarithm, that means you should be able to start evaluating logarithms. So instead of us telling you what the logarithm equals, like for example, you already know log base 2 of 8 is equal to 3, because that was one of the examples we already discussed, we might give you that as a question. We might say log base 2 of 8 equals x, and then we want you to figure out what the x is. To do that, you typically are going to want to rearrange the logarithm in its exponential form. So log base 2 of 8 is equal to x. That's equivalent to the exponential statement 2 to the x is equal to 8. When we see it in its exponential form, I personally think it's a little easier to think of the answer then. Most people, when you say log base 2 of 8 equals x, they don't know what the x is. But if I asked you 2 to the x is equal to 8, most people can come up with the answer once they realize what I'm really asking you is 2 to what power is equal to 8. And so that's how we would recommend you start to think about logarithms when it comes to evaluating them. When you see a logarithm, you need to just realize that what we're asking you is what exponent do we have to raise this number to get that number? So here's a chance to practice what we just said. Each one of these questions is asking you to find an exponent. For example, the first one is asking you 2 to what power is equal to 32. The second one is asking you 2 to what power is equal to 1 over 8, so on and so forth. So at this point, I'd suggest you pause the slideshow and try to work these out, and then join me on slide 9, and you'll see the answers. So here are the answers to those logarithms. I hope you were successful in getting those. Sometimes people usually have a little more difficulty when the answer is negative or when the answer is a fraction, and that's just because people are not as comfortable with fractional exponents and negative exponents. So you might need to go back and remind yourself what fraction exponents mean and what negative exponents mean. But hopefully you were somewhat successful evaluating these logarithms. Now, take a look at this logarithm here, log base 10 of 20. So this is really asking the question, as we just explained, this is asking 10 to what power is equal to 20? Well, 10 to the first power is 10, and 10 squared is 100. So you're looking for 20, which means you probably need something that's in between here. So then the question becomes, how in the world would you know what that answer is? Well, honestly, you don't. There's no way to find that answer by hand. So this is why we said some logarithms you should be able to evaluate without a calculator, but some, frankly, are going to require the use of a calculator. So first, I want to talk a little bit about using the TI-84, which is the calculator we would have available for you in the classroom. You may or may not have access to one at home. If you don't worry about it. We're going to talk about Desmos a little bit later. But if we come back to school, you will need to know how to do this with a TI-84. So you need to try to follow along. And it's pretty simple. First of all, a logarithm with a base of 10, like the problem we were just looking at, that is called the common logarithm. I can't tell you why it's called that. That's just the nomenclature that is used by mathematicians. So whenever you have a log of base 10, some people call that the common log. And because it's considered the common log, sometimes you'll see it written without the base. So if you ever see a logarithm like this, and there is no base, you don't see a little number, then you're supposed to know that the base is 10. So log base 10 of 20 is the same thing as the common log of 20, and sometimes we'll write it like you see on the right here, and we don't show you that little 10. You're just supposed to understand that it's 10. Well, if you have a TI-84, if you look at it, you will see that on the keyboard, just to the left of the button for the number 7, there is a button labeled LOG, and that's exactly what that is. It's the common log. So you can see in the bottom of the screen, I used a calculator to evaluate the common log of 20, and I got 1.301029996. As we said earlier, we were expecting an answer somewhere between 1 and 2, and that is in fact what we got from the calculator. But that is definitely not an answer we would expect you to be able to get without using a calculator. You have to have a calculator to answer that question. As long as we're talking about the calculator, if you have access to a TI-84, if you look at the keyboard, right below the LOG button, you will see another button labeled LN. This is called the natural log. The natural log is a logarithm with a base of e. E is that irrational number that we explained to you when we were talking about compound interest last week. So this is another thing that you just need to know. You just need to know what it's called. You need to know the name. Um, Again, like the common log, sometimes we will just write ln, and then we don't show you that the base is e. You're supposed to know that that's what ln means. So ln means natural log, and that means the base is e. Or you could write it log log base e, but most people are going to write ln. Again, this is not something you could evaluate without a calculator. So if you were asked to find the natural log of 5, you definitely would need access to a calculator. And you can see here that my calculator says the natural log of 5 is 1.609437912. The TI-84 has this nice feature where you can also do logarithms of any base. Not every calculator has this, so if you don't have a TI-84, you may not have access to this feature. But on the TI-84, you can find a logarithm with any base if you go to the Math menu. You have to scroll down quite a bit, and so you see on this screen here that if you go all the way down to option A, you get this command that says log base. And pressing that command will allow you to evaluate a logarithm of any base. So you can see on this screen here, the log base command is how I got the calculator to tell me what is log base 2 of 10. By the way, we just remind you that log base 2 of 10, I would be asking 2 to what power equals 10. And you hopefully know that 2 to the third power is 8, and 2 to the fourth power is 16. So log base 2 of 10 has to be some number between 3 and 4. And you can see that is what the calculator is giving me. It's giving me an answer between 3 and 4. So you can find a log of any base using the log base command on the TI-84. One quick cautionary statement here. Notice the second part of this screen. I tried to do log base -2 of 4 and I got an error. That's because the base of a logarithm can't be negative. Remember, logarithms are related to exponential statements. So log base b of y is equal to x is equivalent to saying b to the x is equal to y. Well, from our earlier discussion of exponential functions, you should know that exponential functions can't have a negative number for the base. If you can't have a negative number for the base, then you can't have a negative number for the base. So the same rules apply to logarithms that applied to exponential functions. Okay, so we're going to wrap things up by talking about Desmos a little bit. In case you don't have access to a TI-84, you can evaluate logarithms using Desmos. In Desmos, if you know how to get to the keyboard, in the lower left-hand corner of your screen, there's a little keyboard icon, and when you press that icon, you get a keyboard. This is part of the screen. I'm not showing you the whole screen here. And once you show that keyboard, if you look in the upper right, you see a key that says functions. And if you click on functions, then it opens this menu that you see right here. And at the top, you have several different menus, and you need to get to the one that's labeled MISC or miscellaneous. So once you go look at the list of miscellaneous functions, you will see that you have a key for the natural log, you have a key for the common log, and you also have a key for log base A. and that lets you do log of whatever base you want, log base 2, log base 4. And so you can get all the same functions that you would get on a TI-84. You can also find them in Desmos. You can also, by the way, just type the word log or ln. You don't have to go to the keyboard. Here's that keyboard icon that I was telling you about. That's what you want to look for to reveal the full keyboard. But if I wanted to graph a log function, I don't have to use this keyboard icon here. If I want a common log, I can just type the letters log. Or if I want a natural log, I can just type the letters ln, and Desmos knows what that means. Remember, we told you that this is a common math term. LOG, everybody who knows math is supposed to know that LOG is the common log, or log base 10. ln is the natural log, which is log base e. So you can use the keyboard icon, or you can just type the letters LOG or type the letters ln. What you can't do with the keyboard, at least I don't know how, is you can't do a log of a different base. You can't do log base 2 or log base 4. Maybe there is a way to do it without going to the miscellaneous functions, but I personally don't know how to do that in Desmos. So if you find out, I'd love it if you would post a comment on the discussion board and share with us how to do that. Okay, at this moment, we would suggest you pause the screencast and try to do what we just showed you on the TI-84 or using Desmos. Each of these logarithms, you will need a calculator or you will need Desmos to evaluate. You shouldn't try doing any of these by hand. When you evaluate these with the calculator, you are not going to get a nice round number. You are probably going to get something with a big long decimal. So we want you to just round your answer to the third decimal place to save some time. So again, at this point, I would suggest you pause the screencast, write down these problems, get a calculator or use Desmos, try to evaluate each of these. And then when you're ready, come back here and we will show you the answers in just a few seconds. So hopefully you had a chance to try to evaluate these logarithms. And now here come each of the answers. Again, remember these answers are not exact. They've all been rounded to the third decimal place. And if you didn't get these answers, I'm going to guess you either used the wrong function. So on some of these problems, you should have used the LOG button, but on other problems, you should have used the LN button. And then on that last one, you have to use the log base command to do log base 2. So make sure you're using the right button, make sure you were careful about rounding, and hopefully you got these answers correct. Okay, so that covers all our objectives for this lesson. We hope that after watching this screencast, you now have some idea of what the definition of a logarithm is. You should be able to take a logarithm and rewrite it in its exponential form. And once you rewrite it as an exponential statement, you hopefully can evaluate it without using a calculator, provided it is possible to do that. Keep in mind there are going to be some logarithms that you will not be able to evaluate without a calculator. So we also showed you how to do that using the TI-84, but you also should be able to do it with Desmos if you don't have access to a graphing calculator. This week, because we're having you do one final assignment on exponential functions, we're not going to have you do another assignment on logarithms. We still need to talk some more about logarithms next week, so there'll be a chance to really check your understanding on it next week. For now, though, if you want to, I would just recommend you go back, look at slide 6 again. That's where we had several examples of how you could rewrite logarithms in exponential form. Go back and look at slide 8, and that was the slide where we practiced evaluating logarithms without using a calculator. I think people especially probably have trouble evaluating logarithms when they are equal to a fraction or equal to a negative number. and that's because you got to remember logarithms are essentially exponents, and I know plenty of students still struggle a little bit when exponents are fractions or negative. And then the last one was slide 17, and that's where we had the questions that you had to use a calculator or Desmos to get the answer to the logarithm. So if you'd like to go back and look at those slides again to get a little more comfortable with this, maybe that would be a good thing to do. But there's no other assignment you have to do this week on logarithms. We will do some more practice with it next week. That's it, gang. See you next week.